Alright, this video is going to be about Notes 4, page 5 of Calc C. And still talking about geometric series. Um, page 5 only actually has 2 questions on it, but it has a lot of parts. So let's get started. So in the first question, we're told that f of x is the summation from 1 to infinity of x over 3 to the n minus 1. Which if you look at it, is actually a geometric series. It's just that r has an x in it. So if we wrote this out, we would get something that looks like an infinitely long polynomial, which maybe you already know or maybe you'll learn eventually. It's called a power series. So we are kind of asked to evaluate this function at a couple of x values, and then 2 other questions, which I'm actually going to answer first. So the first one is, what are all values of x for which the function will converge or have a sum? So if I plug in a value, I'll get a valid output. So let's take a look at that. So knowing that it's geometric, we have to figure out what r is. So r is x over 3 because that's the thing being raised to a power. And then I know that for a geometric series, it converges when the absolute value of r is less than 1. So the absolute value of x over 3 is less than 1, which I can solve. Give me the absolute value of x is less than 3. So as long as the absolute value of x is less than 3, I can plug into this function and get something back that makes any sense at all. So I'll get a convergent series back. So let's take a look at the next part, which says, on this interval, so when x is between -3 and 3, I want to rewrite the function so that instead of having the summation, I just have kind of an explicit function. So let's treat it as geometric, right? So it starts at n equals 1, so if I take 1 and I plug into this thing, I actually just get 1 back. So 1 over 1 minus, and then the ratio, which is x over 3. And then I can actually simplify that to get 3 over 3 minus x for the absolute value of x is less than 3. So that's actually equal to the function on that particular interval. So as long as I'm between -3 and 3, plug in. All I really need to do is 3 over 3 minus x, and it gives me the value of the series. So now I'm asked to evaluate, if possible, at 4 different things. So the first one is x equals 4. Well, if you look at x equals 4, that's greater than 3, which means that if I plug 4 in, I get a divergent series, which isn't any good to me. So that's not going to be possible, so it diverges. For b, we're dealing with x equals -2. The absolute value of -2 is less than 3, so I just plug straight into my closed form, and I get f of -2 is 3/5. So you can see once you've worked out where it converges and what function it converges to on that interval, evaluating is as easy as evaluating any function. The next thing is x equals pi. Well, pi is greater than 3, so again we're going to diverge. And then finally we have x equals e. Well, e is like 2.718, so that's in the interval of convergence. So f of e is 3 over 3 minus e. And there you go. So that's the entirety of the first question. It's just that I answered it out of order, so let's just make sure it kind of looks right. The interval of convergence is right here. It's the absolute value of x is less than 3. Or you could write -3 is less than x is less than 3, if that's how you want to do it. And then the function it converges to on that interval is right here. So that's the sum on the interval. Will always be 3 over 3 minus x, which is a super fast way of evaluating it. You just have to realize that. So let's move on to the second question, where we are given f of x is x squared minus x cubed plus x to the 4th minus x to the 5th plus ... So the first question is to determine whether f of x has a maximum, minimum, or neither at x equals 0. Well, something that you're going to run into a lot when you're dealing with series is that you're going to have to use the second derivative test for these sorts of things, because the first derivative test, how are you going to do a number line when you have an infinite number of terms and you'd have to figure out positive to the left, negative to the right? It's just like a lot of weird work. So what we'll do is find f prime, just power rule our way through it. And we get this, ... and then I'm going to go ahead and find f double prime at the same time. So f double prime, just using the power rule again, gives me this. Now I'm going to figure out f prime of 0 and f double prime of 0, and that should be enough information unless it's inconclusive, in which case we have a problem. It's not going to be inconclusive though, you can kind of see already. So f prime of 0 is 0 by plugging in. F double prime of 0 is 2 by plugging in, which is greater than 0. So we have a horizontal tangent line, and at that horizontal tangent line, the function is concave up, which means we have a relative minimum at that point. And that's by the second derivative test if you want to write it, but we've met the condition, so we're good to go. Now we want to write a function, I don't know why I called it g of x. So g of x is equal to f of x on some particular domain, then we want to state that domain. So I'm looking at f of x, and it looks to me like it's geometric, and remember, you can find r by dividing consecutive terms. So I'm going to do negative x cubed divided by x squared gives me negative x. I'm going to check that by doing x to the fourth divided by negative x cubed, which also gives me negative x. So r is equal to negative x, and the first term of the thing is x squared, right, just by looking at it. So it's first over 1 minus the ratio. So x squared over 1 minus, and then the ratio is negative x, which clearly simplifies. And then r is negative x, right, that's our ratio. So it will converge when the absolute value of r is less than 1, which means the absolute value of x is less than 1. So that's the answer to B. That's the function that it converges to on its interval of convergence, which is negative 1 to 1. Now we're supposed to find f of 1/3. So f of 1/3 is the same as g of 1/3 because 1/3 is in the interval. And then we just plug in. And this you can work out. So it's 1/9 over 4/3, which is 3 over 36 or 1/12. And the next question is a little weird. So we have to use our function to somehow evaluate this, which if you just compare what you're looking at to what we've done so far, you'll notice that the 2, the 3, the 4, the 5, that corresponds nicely to f prime of x. So it looks like this is just f prime of x with 1/2 plugged in. So what I'm going to do is I'm going to say f prime should be equal to g prime of 1/2. Find g prime of x and plug in 1/2. And that should do it. So bottom derivative of the top minus top derivative of the bottom all over the bottom squared, so quotient rule. And then plugging in 1/2, I'll be honest, I use a calculator to plug that in, but I get g prime of 1/2 is 5/9. And I'm going to go ahead and do the first question on the top of page 6. So I want 3 different series that sum to 5/3. If you think about the sum of a geometric series, it's first over 1 minus the ratio. So if I pick the first term, then I'm going to have to solve for the ratio, and there's a chance that the ratio that I get will inadvertently end up being greater than 1. Its absolute value will be greater than 1. That's a problem because basically this formula will give you junk answers if you plug in ratios that are outside of the interval. So instead what I'm going to do is I'm going to start off with the ratio. So I'm going to choose my ratio as 1/2. I'm going to solve for the first term. So if I go with 1/2, I get a first term of 5/6, and from there I'm going to write my series. So 0 to infinity, 5/6, and then 1/2 to the n. And then I just do that again. So I'm actually only going to do it twice, I think. So I'm going to go with r is negative 1/2, solve for that, and I get the sum from 0 to infinity of 5/2, negative 1/2 to the n. I'm just going to do 2 of them because I think you get the idea at this point. I hope you found this helpful. Good luck, and I'll be back in another video.